Hi guys, in this video we're going to see an introduction to momentum. We'll look at a momentum example and then finish with a summary.
Now you may have heard the word momentum being used in day-to-day life. In physics we say that when something moves, it has momentum. So here if this car is moving, then it will have momentum. And we give the momentum the symbol P. This is all very well, but what actually is momentum? Until we write down a proper equation for it, for the rest of this slide you can imagine it as being, how hard is it to stop something? If it's difficult to stop it, it's got a lot of momentum. Let's focus more now on what momentum actually is. Momentum is a quantity that depends on the velocity of our moving object as well as its mass. So the momentum depends on, for example, the speed of the car and what its mass is. With regards to the dependence on mass, an object with a higher mass will have a larger momentum. For example, if a car and an aeroplane were both to travel at the same speed, then the aeroplane would have more momentum. And a mathematical way to write down this relationship would be to say that the momentum is proportional to the mass. We also said the momentum would depend on the velocity. In particular, objects with a higher velocity have larger momenta. So if we were running faster, we would have more momentum than if we were running slowly. And again, the mathematical way to write down this statement would be to say that the momentum is proportional to the velocity. Now we have two proportionality rules here, and it turns out we can put both of these proportionality rules into one equation for the momentum. We say that the momentum is equal to the mass multiplied by the velocity. As for the units in this equation, the mass is given in kilograms, the velocity is in meters per second, and the momentum is measured in kilograms, meters per second. Okay, now let's calculate some momenta, and remember that the momentum increases when either the mass is larger or the velocity is larger. Imagine an elephant is chasing a mouse, and imagine they are both moving at the same speed of 6 meters per second and in the same direction. So they're both moving at the same speed, but if the mass of the elephant...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.